Hello, and welcome to my videocast. My name is Dr. Richard Walters. I'm a physician. I've been practicing emergency medicine for the last 35 years, and I've been teaching medicine to doctors for the last 10 years. And today, I would like to talk to you all about medical cannabis. Now, I'm a big proponent of medical cannabis, but I'm not here to convince you to use medical cannabis. I'm not here to convince you to legalize medical cannabis, because that has already happened in New Zealand. In 2018, medical cannabis was made legal, and starting 2020, medical cannabis will be a reality. So, all you doctors out there need to be prepared. You can love it, you can hate it, but the reality is your patients are going to come to you for advice. They're going to come to you saying, "Doctor, I've been taking this arthritis medicine, but it's not working very well. Do you think I should be taking medical cannabis?" I get neighbors that ask me that all the time. What are you going to tell your patients? "Oh, geez, I don't know. I don't know anything about medical cannabis. Why don't you go on the internet and find out about it?" So you're going to tell your patients to go on the internet, and they're going to get a lecture on medical cannabis from somebody that calls himself, I don't know, Stoner 69, or smoking a joint while they're giving a lecture. I said, you really owe it to your patients to know about medical cannabis. They come to you for advice, and you need to be able to give them good advice. And that's what we're going to go through today. Okay, I'm going to start by saying, let's admit it, cannabis has an image problem. I mean, with names like pot, reefer, grass, marijuana, dope, it's obvious. 70 years of drug prohibition will do that to you. 70 years of propaganda, 70 years of fake news. I mean, that's the current euphemism for that type of stuff. We've been told it's illegal. Getting stoned is immoral. We've been told that it's unsafe. We got movies like Reefer Madness. I got some slides from these movies. These were movies that were done in the 30s to promote cannabis prohibition. My first slide, Reefer Madness, the deadly scourge that drags our children into the quagmire of degradation. And the second slide is even better, which shows a young couple in the background shooting up, a large syringe in the foreground, and a quote, "What happens at marijuana parties, weird orgies, wild parties, unleashed passions." So you can imagine in the 30s, this is what the politicians were seeing. And somebody actually thought that people shot up cannabis. And that brings us to our slide number 6, which shows some of the movie spokespersons, the epitome of responsible cannabis use. Cheech and Chong. There's Jeff Spicoli, which is Sean Penn in the movie Fast Times at Ridgemont High. And there's Snoop Doggy Dogg. Now, if these three people are endorsing your product, you have a problem on your hands. So you can imagine when a patient says to you, "Oh, listen, doctor, thanks for your recommendation, but my son already has enough problems with his seizures. We can't have him stoned out of his mind all day long." What the media won't tell you is that cannabis was actually used for medicine, used responsibly for over 4,000 years. 4,000 years of usage, and never a reported death due to cannabis. All right, and that brings us to, what do you already know about cannabis? Or I should say, what you think you already know about cannabis. 1, that medical cannabis gets you stoned. 2, that nobody's ever died smoking pot. 3, marijuana smoking causes as much lung cancer as tobacco. 4, smoking pot causes the munchies. 5, smoking pot makes you veg out, or rather couch lock, where you just want to sit in the sofa all day long and don't do anything. Number 6, smoking marijuana ruins your brain. And number 7, marijuana is a gateway drug to harder drugs. These are some of the myths that you probably already know. Hopefully by the end of the talk you've decided otherwise. We'll keep this slide and hopefully go back to it later. All right, so what is medical cannabis? Well, medical cannabis is A, pot grass, marijuana, reefer, dope, or whatever name you've been using for it. And B, cannabis grown to a pharmaceutical standard. So when I say pharmaceutical standard, what are the standards? Well, number 1, the government requires the API, or the active pharmaceutical ingredient, to be listed. And I'm presuming by that mostly they're concerned about the THC and the CBD, and probably not some of the others, but we'll go into that later. And number 2, that the strength of the medication be consistent. So if you're taking a fixed quantity, let's say you're smoking a joint and that joint is labeled at 5 milligrams, every joint that you smoke that's labeled at 5 milligrams should be a consistent 5 milligram dosage. Number 3, that the medical grade cannabis needs to be devoid of any impurities. One of the interesting properties of cannabis, it tends to absorb heavy metals pretty strongly. And actually, hemp has been used for years to clean up toxic waste dumps, because it removes the heavy metals from the soils and concentrates it into the cannabis. So obviously testing for heavy metals is important. Another thing, that they test for molds and yeast. Another thing is tested for no pesticides, or there's a limit as to how much pesticides and which type can be available. Certain pathogens like E. coli are not allowed. There's a maximum amount of plant material that can be in the preparation. That no solvents are around, or there's a limitation on solvents. So if you're using ethanol to extract the cannabis oil from the plant, the government has a limit as to how much ethanol can be in the final product. And last, no added pharmaceutical agents. So essentially, you're not allowed to add something like synthetic THC to your medical cannabis. Another requirement is that all medical cannabis be properly labeled, that the packaging be childproof, that the manufacturer name needs to be on it, their license, the batch number. And although they haven't voted on it yet, probably that some proof that the product is stable over a period of time, and that there'll be probably an expiration date required. So that tells us what medical grade cannabis is. But I guess the next question is what is cannabis? I mean, cannabis is a plant. Cannabaceae family. If we're doing Botany 101, it's a plant in the Cannabaceae family, of which there are 3 known species: Cannabis sativa, Cannabis indica, and Cannabis ruderalis. There's pictures of them. It isn't important that you be botanists, but maybe know a little bit about the differences might be useful. The classic cannabis is Cannabis sativa, which is a tall, thin plant, sometimes getting as high as 5 meters. It has thin leaves. The Cannabis indica is shorter, wider. There's some mythology about the effects of Cannabis sativa versus Cannabis indica. The myth that is Cannabis sativa is more of a head rush, a creative, energetic high, and the indica is a sort of a relaxing motor high that makes you just want to sit there. But most of our studies show that there's almost no pure sativa and indica left in the world, and everything that is being grown these days is some sort of hybrid, which brings us to ruderalis, which is a small little scruffy little plant. Looks like almost like a wheat plant. It's just barely a meter high, and typically has almost no phytocannabinoids in it. And so you ask, why are we even worried about it? And I go, well, because the plant is fast growing and it flowers with automatically. It's been crossbred with some of the other cannabis species. And so what you're seeing today is mixtures of all these. The next slide I have here is sort of the anatomy of the plant. It's a picture of the flowering buds at the top of the cannabis plant. And basically, this is where the active ingredients are stored. They're stored in these small vesicles called trichomes. And if you look at them, they almost look like sugar crystals. That, for the most part, there's not a lot of THC in the leaves and the stalks and the stems. I mean, there is some. But the real high quantities of the active ingredients are stored in the trichomes of the plant. So you pretty much have to wait until the plant is flowering and that the trichomes are maturing before you can harvest the plant at its maximum peak. Okay, which leads us in, what is it in cannabis that causes all the medical effects? I mean, what is it in cannabis that makes us interested in it? Well, first and foremost are the cannabinoids, which is a family of compounds. Presently, there's about 130 plus of them identified. And that's not to say that there are 130 different cannabinoids in each specimen of cannabis. There isn't. There's a varying amount. If you test for them, you can find them. We normally test for the CBD. We normally test for the THC. Some of the other ones you can test for if you want to. Obviously, it costs money, and so some of them weren't even known to exist 10 years ago. So some of the studies done on cannabis 10 plus years ago is suspect because the active ingredients were not entirely known. The second important compound in cannabis is a group called terpenes. And terpenes turn out to be quite an interesting group of chemicals. They are previously known, they're not unique to cannabis. Basically, they're otherwise known as essential oils. And there are, 100 different terpenes known. And we'll go into the terpenes later, but suffice it to say, these were compounds that were previous known to us, present in pine oil and oranges and lemons and things that smell good. And the herbalists around us have been making claims about how these terpenes affect your mood, and we've been essentially ignoring them. The next category is flavonoids, which are compounds that create the different colors that are in cannabis, which are not particularly useful for us pharmacologically. And the last compound, D, is that one needs to admit that the vast majority of cannabis is just plant fiber. And plant fiber, leaves, wood, stem. And the reason that's significant is because, well, we already know that if you burn firewood, there's probably produces about 1,000 different compounds. And some of these compounds are creosote and phenols and they're known carcinogens. So by extension, you would figure that if you're smoking cannabis and if it's got wood fiber in it, which is exposing you to carcinogens, that essentially there'll be a higher incidence of cancer in people that's smoking cannabis. All right, we already alluded to the fact that the main active ingredients in cannabis are a group of drugs called cannabinoids. And there are basically plant-derived cannabinoids called phytocannabinoids, and there are endogenous cannabinoids that are found in human bodies, which are called endocannabinoids. But we want to talk about the plant-derived phytocannabinoids. And I alluded to the fact there's about 130 plus that are known. Let's just go through some of the basics here. So the primary cannabinoid that everybody knows about is THC, which was first isolated by Raphael Mechoulam in Israel in 1964. Raphael Mechoulam is sort of the godfather of cannabis research. If you look at this slide here, you'll see that he discovered cannabidiol, he discovered THC, he discovered cannabigerol, which is CDG, he discovered CBC. So he's a heavy hitter in the cannabis research, and he did his research in Israel. So one of the issues with research is you need the government's approval to do research. So that's really stifled research certainly in the United States. But Raphael Mechoulam was a research pharmacologist or a research biochemist, and he went to the government to ask for research, and it turns out that a couple of his ex-students were now in government positions where they were the persons that were giving approval. So he had no problem doing cannabis research. So all throughout the 60s, he came up with all these discoveries, said, in cannabis, there's all these active ingredients, and these are what they are. And the whole world went ho-hum with a big yawn, and essentially nothing happened. So let me review a little bit of some of these cannabinoids. So there's THC, which is the drug that gets us stoned. There's CBD, which you've probably heard a lot about with all its medicinal properties, and we'll go through that later. There are the acid derivatives of THC and CBD, which is THCA and CBDA. And in order to activate these drugs, you need to decarboxylate it and take a carbon atom off of it. And so how do we decarboxylate it? Well, generally just by heating it. So, when you smoke cannabis, you are activating the THCA and turning it to THC. And when you are smoking CBD, you are turning the CBDA into CBD. And that's all well and good. You probably don't even need to know that. However, in raw cannabis, most of the cannabinoids are THCA and CBDA. And if you smoke it, no problem. You activate it, the THC and the CBD. But if you eat cannabis, which people do, they turn it into brownies or gummy bears. Certainly when you make brownies out of it, you cook it, so you activate it. But if you were to just add it to gummy bears, or let's say you extract the oil in the form of a tincture using alcohol, then the active ingredients THCA and the CBDA have not been activated. And although THCA is slightly intoxicating, it has slight psychogenic effects. It is not the same. It does not have the same properties as THC. And the same goes true with CBDA. It doesn't have the same properties as CBD. The next phytocannabinoid on our list is CBN. And CBN is considered sort of a breakdown product of the THC and the CBD. So if you have cannabis laying around for a long time, it oxidizes the THC, it oxidizes the CBD, and it forms CBN. And CBN is noted to be somewhat sedating. So you have a couple of phenomena that occur. One of it is if you do research on cannabis, and let's just say for argument's sake, the research study shows that people are very sedated, and then you do another research study and it doesn't show the same effect, and nobody knew to check the CBN levels. I mean, I might imagine that if you got some government-supplied cannabis, who knows, it could be sitting in a warehouse for a year or two. Who even knows? And so without knowing the CBN quantity in any strain of cannabis, you really can't explain or predict what the effects might be. And another phenomenon that occurs is that although you can have a strain of cannabis that is predicted to have a high THC level and a high CBD level, if the cannabis is harvested late in the cycle, apparently in the trichomes, a lot of the THC and the CBD is converted to CBN, and most cannabis connoisseurs will tell you that if you pick the cannabis too late, it's much more sedating. The next two phytocannabinoids are CDV and THCV. The V stands for the varin moiety, which is added to the molecule. And apparently when you add the varin to the cannabinoid, it turns a THC into a THC blocker, and it turns the CBD into a CBD blocker. So whereas THC will give you the munchies, it makes you hungry, it turns out that THCV does the exact opposite. And the drug companies have discovered this, and they go, wow, this is great. This is a fantastic phenomenon. We could make a lot of money on it. So they've developed THCV, put it in a pill form, spent a lot of money, tried to get it approved by the government to help people with diet, and it was released as a drug called Rimonavant, and it didn't actually pan out the way it was supposed to be. Rimonavant apparently causes depression and suicidal ideation. So after investing nearly $500 million in the drug, it has been withdrawn from the market, and it's not something you're going to see. Might not even read about it if you don't look real hard. But that's not to say that cannabis with THCV and high levels of CBD in it won't suppress appetite, and that's not to say that the cannabis with these cannabinoids in it is unsafe and likely to cause depression and suicidal ideation. To date, there's no evidence showing that, and who knows what the future lies with CBD. Next cannabinoid is CBG, and CBG is actually a precursor to the other cannabinoids made in the molecule, and there is at least one company out there that is highly marketing the CBG for its anti-inflammatory effects, and you'll probably hear a lot more about CBG in the future. CBC, cannabichromine, is not well documented in the literature. It's known. I don't think there's a lot of studies done on it, and I didn't note anything particular about its properties. So our researchers have discovered that, okay, so we have these phytocannabinoids which seem to modulate processes in the human body. I wonder if there are any receptors in the body. I wonder where they act. And sure enough, Devane in 1992, and I think once again Raphael Mechoulam, probably in 93, discovered that there are receptors, and fortunately the first receptor was endocannabinoid 1, EC1, and it was stimulated by THC. And the second receptor that was discovered was called EC2, and it apparently is stimulated by CBD. Now, classically, it is taught that the EC1 receptors were primarily in the brain and the nervous system, and that's why when you stimulate them with THC, it has psychogenic effects, and that the EC2 receptors tend to be distributed throughout the body, and that's why the CBD doesn't have any psychogenic effects, although subsequently we've learned a lot more about the receptors, and I'm going to show you endocannabinoid receptor map in a second, and you're going to see that they're scattered throughout the body. So, naturally, after you discovered that there are, these ligands, that there is a phytocannabinoid and a receptor that it turns on, or that it stimulates, one would say, well, maybe the system has some endogenous, maybe there are some endogenous cannabinoids in the bloodstream or in the body that are doing this. And lo and behold, in 92, we discovered AEA. And AEA, otherwise known as amantadine or arachidonyl ethanolamide, tends to stimulate the EC1 receptors. And you go, oh, okay, so that the body does do this. There's a whole system in the body. And then subsequently we discovered 2-AG, which is 2-arachidonyl glycerol, and it stimulates the EC2 receptors just like CBD. And lo and behold, you go, holy mackerel, we had this whole system in our body that we've never known about. I mean, we've known about the endocrine system, we knew about the autonomic nervous system, and all of a sudden we have this endocannabinoid system in our body that turns things on, or stimulates them, or modulates them lower, and we've not known about it for all these years. And it's been 100 years since we've discovered insulin, for instance, but we haven't discovered the endocannabinoid system because, well, the government wouldn't let us do any research on it. And now we've got this system, and I'm going to show you the slide here of the endocannabinoid receptors, and as you can see, they are everywhere. And you look at it and you go, there's CB2 receptors on the spleen. And you go, I wonder what we could do. What happens when you turn the spleen up or you turn the spleen down? Might there be some medical usefulness on it? I mean, we've had ITP around for a long time. We've had a hard time treating it. Sometimes we have to remove the spleen. Sometimes we have to give steroids. Might it be possible to take an old disease that we've had problems treating and find a new treatment for ITTP? We turn the spleen down. So what about, there's receptors in the pancreas. What happens if we stimulate the pancreas? Well, we already know. We've had insulin for many years, but we seem to be somewhat at an impasse here. We've been giving people insulin, and we haven't cured diabetes. We still have a lot of problems with it. Might we have a new drug? Might we have a new tool in our toolbox? And I'm not going to say, yes, we do. What I'm going to say is, there is a lot of promising research that's coming out and saying that, oh my God, these drugs actually seem to help. Well, I'm not going to make any medical claims now, but I think, watch this space. There's a lot happening here. Okay, so the next thing I want to talk about is the terpenes. We had mentioned them earlier. Terpenes are essential oils that give cannabis its smell, and there are a lot of studies that show that the terpenes do more than just simply make our cannabis smell good. There have been some studies done by Ben Shabbat in 1998, and once again, Raphael Mechoulam in 99. There's a great study done by Ethan Russo in the British Journal of Medicine in 2011, and they basically state that terpenes act on the cannabinoids. Whereas the cannabinoids are modulators, the terpenes tend to modulate the modulators. The terpenes enhance or detract what the cannabinoids are doing. So the first terpene we want to talk about is pinene. Now, pinene is basically the essence of pine, the smell that we have from evergreens. And it's been known about for a long time. The chemical companies make it, and they add it to, floor cleaner. United States, there's a famous product called Pine Sol, and it's some sort of floor solvent. Probably doesn't smell particularly very well, and they add some pine scent to it, and all of a sudden everybody loves the smell of their nice clean floor, and that's all attributed to the pinene. So the herbalist out there will tell you that pine causes alertness. It enhances our memory. It's been used as a bronchodilator for hundreds of years. The Japanese, traditionally, they have a saying, and I don't know what it is in Japanese, but it basically translates to taking a pine bath. Famously, they would state, why don't you go for a walk in the woods, smell the pine trees. It will increase your alertness. It will help your memory. It will improve your mood. And I can remember, this has got to be maybe 40 years ago, I was in Germany and I went to a health spa in Baden-Baden. And they had all sorts of rooms with all sorts of different things. And one of the rooms, they had nothing but pine boughs, which they were heating over a fire, and it was releasing the pinene into the air. So the air was permeated with pinene, and it was supposed to be invigorating. So, so the effect of pinene's been known for a long time. So knowing that, so if we had some medical cannabis, and let's say you wanted to give it to somebody in the morning and for them to function at a high level, something that added something to their memory and to their alertness, a high amount of pinene would be a good thing. So that leads us to our next terpene, which is limonene. And again, limonene is a very common essential oil. Most of us can go home and we probably have some dish soap, which is lemon scented, and everybody thinks that lemon scented dish soap smells better, and it's wonderful. But I mean, the drug chemists have been making it for many years. And the herbalists will tell you that it improves your mood. There's been studies show that it kills cancer and that it has antibiotic and anticonvulsant properties. I always wonder when, somebody says something like limonene has antibiotic properties, why haven't the drug companies exploited that for a long time? I know we've been looking for new and better antibiotics all the time, but that being said, limonene makes the claim as to be have antibiotic properties. But let's talk about the fact that it has anticonvulsant properties. So we already know that we have used CBD in children for certain seizure disorders, and it works quite effectively. So might it be that we can add some limonene to the medical cannabis and enhance its anticonvulsant properties? So then the next terpene is caryophyllene. Caryophyllene is the smell that we get from black pepper, also in the herb thyme, also in oregano. I think it's also in basil or bay leaves as well. But anyway, caryophyllene is known to be a gastroprotectant. It has some anti-inflammatory properties, and it has some autoimmune properties. I'm not exactly sure what that means, but there are lots of studies on these things. So, medical cannabis has been touted as a very useful drug for arthritis. So you have medical cannabis has anti-pain properties, has anti-inflammatory properties. Might it be that we can add some caryophyllene to our medical cannabis and enhance its anti-inflammatory processes? Sure, why not? Sounds good. Number 4 on our list, myrcene. Now, myrcene is the most common of all the terpenes. And myrcene is what gives cannabis its skunky scent. I am told that it is the scent found in mangoes. I'm not a big mango eater, but I've never known them to be skunky. But anyway, myrcene turns out to be the smell that the drug dogs smell. Apparently, cannabis without the myrcene, or cannabis without the terpenes, is basically odorless. But the drug dogs fixate on the myrcene. So if you have cannabis in the fender of your car and you go over the border, it is the myrcene which gives you away, and that's what's going to get you in trouble. So myrcene has some properties. It is a sedative hypnotic, which means it makes you go to sleep. It too has some anti-inflammatory properties. It has also been shown to be a pretty good analgesic. Of interest is that myrcene has been noted to be the cause of the couch lock effect we mentioned earlier. So couch lock is when you smoke some cannabis and then you just feel like you just want to melt into the furniture. You just want to lay there, relaxed, mellow, don't want to get out of the bed or the chair or the couch for the next 4 hours. And all the studies seem to show that the strains of cannabis that are high in myrcene seem to be the ones that cause the couch lock. So knowing this, you certainly wouldn't want to prescribe, a medical cannabis which is high in myrcene to somebody and then send them off to work. I mean, obviously, high myrcene strains of medical cannabis are most effective at night, to put somebody to bed, put somebody to sleep, to relax them after a long day of work, or somebody that has intractable muscle spasms who are not going to go to work. So it is important to note what terpenes are in the medical cannabis, and as we alluded to earlier, the government is going to require us to list the active pharmaceutical ingredients in our medical cannabis, but it's doubtful that the manufacturers are going to be listing the terpene content. The next terpene is nerolidol, which is the smell that's found in ginger, in jasmine, and in tea tree oil. And it has some properties of its own. It's been known to kill parasites, mites, head lice. It has some antibacterial properties, some antifungal properties, and some studies shows that it's used in mice to sedate them. It's also been shown to improve skin penetration. I go, oh, that's interesting. How useful could that be for us? I go, well, skin is kind of hard to penetrate. I mean, it's supposed to be waterproof, and you want to massage some drugs into your skin. You would like something that would help it. And there are a lot of people that use cannabis or CBD oil or THC oil for their skin. And so might it be useful if you added a little nerolidol into it to help improve the amount of THC or CBD that is actually absorbed in the skin? Sure, of course. Now I'm posting a slide here which was done in 2009, where they postulated how is it that the terpenes can modulate the cannabinoids, and there's a bunch of effects there, and I actually find it a little boring, so I'll put it up here. But suffice it to say that the terpenes modulate the modulators, and that's the important thing. Also, it's been coined as the entourage effect, that the cannabinoids themselves have some action, the terpenes have some action, but it is the sum of all the parts. It is the entourage, the entire entourage of all the chemicals that are in the medicinal cannabis that makes it superior to the parts in and of itself. And I always like to use the analogy of a glass of wine, a glass of red wine. We know what's in it. There's mostly water, there's some alcohol, there's some sugar, there's some food coloring, and it gets you intoxicated. And we enjoy that effect. And we could artificially make some wine by taking a little water, some 5% alcohol. We can add a quantity of sugar. We can add some red food coloring. And I could give it to you, and you could drink it, and you could say, yeah, but it would get you intoxicated just as fast as the finest glass of Cabernet Sauvignon. But somehow, it just isn't the same. And any wine aficionado will tell you, you can drink this artificial wine that we've created in a lab, but without the terpenes, without the flavonoids, it just isn't the same. And I think the analogy is perfect for medical cannabis, that without the terpenes, it is just simply not the same. It is the sum of the parts. It's the entourage effect that makes cannabis what it is. And the next slide we're going to look at is the pharmaceutical drugs. So, and that's nowhere does this entourage effect become more obvious than when you start talking about the pharmaceutical drugs. So, the pharmaceutical companies have known, okay, there's THC in cannabis, and it seems to do a lot of good things. Why don't we synthesize it in a lab? We'll put it in a pill. It'll be white. It'll be pure. And we'll give it to patients. And, it takes a lot of research and a lot of money to take something like that. And then you have to jump through a lot of hoops in order to get the government to approve it. So synthetic THC was approved in the United States under the name of Marinol. In Europe, it was dronabinol. And it's still available. So initially, they approved it in the United States to be used in AIDS patients. So, AIDS patients, generally speaking, as they get very sick, they go through this wasting disease. They lose weight, they refuse to eat, and they die quickly after that. And so the thought was, well, THC stimulates the appetite. It'll keep these people alive and healthier a little bit longer, and they won't waste away quite as soon. And they presented it to the regulators from the U.S. government, and they reluctantly said, well, these guys are going to die anyway, and, what does it matter if the THC causes liver cancers or they grow two heads? These people are going to be dead in a couple of months, so we might as well approve this drug, let them have it, and, that would be the merciful thing to do. And so it was used. And then subsequently later, they approved Marinol for cancer patients because cancer patients undergoing chemotherapy have a lot of nausea, vomiting. And the drugs that we've been using for nausea and vomiting don't seem to be sufficient. So, they go to the government and say, well, what about these guys, can we not give them THC? And the government said, well, okay, only after you've proven that the other medications for nausea and vomiting haven't helped, then you can use THC. And again, it was one of these things like, well, these people are going to die of their cancer anyway, so we aren't too concerned if it causes brain tumors or makes them stupid. And what the heck if you have end-stage cancer dying? Who cares if they're stoned? I would probably want to be stoned out of my mind anyway. And it seems like the merciful thing to do. So Marinol's been around for a long time, and the drug companies probably spent $500 million on it to get it approved, and I'm sure they're chomping at the bit to figure out other uses for it. But one of the problems is, THC, Marinol is actually a crappy drug. I mean, it's crappy in that it makes you feel bad. Whereas you smoke a joint, it's got THC and it's got the terpenes in it and it's got some CBD in it and some other cannabinoids in it. And most people enjoy the effect, obviously, otherwise they wouldn't be doing it. But when you synthesize synthetic THC without the entourage effect, without all the other drugs, most of the people say, yeah, it makes them feel a little squirrely, a little bit uncomfortable. Yes, it helps. It helps stimulate their appetite. Yes, it helps their nausea and vomiting. But, by and large, 99% of these patients are going to tell you that they'd rather be smoking good old-fashioned cannabis. But anyway, drug companies would rather not, And as you can imagine, they've got a lot of money tied up in it, and would prefer you not. The next pharmaceutical that you need to know about is Epidiolex. Now, Epidiolex is just a pure synthetic CBD. Doesn't have any THC in it. And Epidiolex has been shown to help intractable seizures, predominantly the seizures that are seen in Lennox-Gastaut syndrome or Dravet syndrome. These are rare pediatric seizure disorders. I mean, I've been practicing medicine for a long time. I've never seen anybody with either of these syndromes, but apparently these children have seizures, 80 times a day in some cases, and nothing seems to work. And I'm not quite sure how they got hold of some CBD, but the CBD helps. And it was one of these things where, the government didn't want to approve the CBD, but you have all these mothers and you have, pictures of their poor child that's seizing, and the CBD seems to help, and the government really couldn't stop it. And so anyway, Epidiolex has been approved. The cost is prohibitively high. It's about $32,000 a year, which is, ridiculous. I mean, my kid had Lennox-Gastaut syndrome. You could be sure that I'd be growing some cannabis in my backyard, and I'd be saving myself $32,000 a year, even if I had to risk incarceration in prison. That's for sure. The next drug that you need to know about is Sativex. And I believe Sativex, out of this list of 4 drugs, is the only one that is approved for usage in New Zealand. Now, Sativex is a combination of both THC and CBD, and it is approved in New Zealand for patients with intractable spasms secondary to multiple sclerosis. However, up until the approval of medical cannabis, the only time you could actually get Sativex is by getting a specialist, i.e. either a pediatrician or a neurologist, to write your prescription, and then it had to go to the government, and then the medical board, or the Department of Health rather, had to approve it, and then it would have to be exported from Canada or United States, then imported into the United States. So the cost of Sativex is about $1,200 a month. And it's not paid by the pharmac companies, so you can imagine that was a problem. And the last drug on our list is rimonabant, or otherwise known as Acomplia. And I mentioned it earlier, rimonabant is a EC1 and EC2 antagonist. And it was first marketed in 2008, and due to the high risk of suicide and depression, it was taken off the market, and it's not likely you're ever going to see it ever again. So I've been talking a while, and there's a lot I've said, and there's a lot I could still say, but I think this is a good time to stop. We'll turn this into a couple lectures. And if you have any comments, any suggestions, certainly if you have any corrections, please add them below, and I will respond to them, and I will apologize for anything that I've stated that's incorrect, with my deepest apologies. Thank you.